welcome back, everybody. I just, like a half hour ago, posted our first homework assignment, which will be due on Wednesday. So you will find it at the class website, which you can get to by following, this QR code on the syllabus. This one here. It's also, if you go to Blackboard, there's not much there, but you will find a link to this place where you can find the homework assignments. And also, you will see there the recordings of the first two classes. That's where every time, every day I'm recording these, and they will appear over there. I will also remind you that your math chat questions are due in another week. So the first homework assignment is due on Wednesday. That's September 11th, and then you got another week to think about your interesting little questions. I've got some, about 10 people have sent theirs in already, so thank you for those. And I am interested to see what the rest of you have. Any questions about the homework or anything like that? So as we discussed, the first day, you're gonna just write, when you go to get the assignment, you'll see just like a PDF of questions. It's not meant to be a worksheet that you print out, it's just those are the questions. You write the answers on your own paper, and then send them to Gradescope by taking pictures. I hope that makes sense to everybody. Please let me know if that doesn't work out. If you join the class lately, the Gradescope is probably not set up for you, but I will do it as soon as possible, and if anybody is having trouble with that, please let me know. All right, great. Let's continue then talking about this voting stuff that we started last time. If you're just joining us, you can watch the previous classes and get yourself caught up. I hope that works out for everybody if you missed class. We, at the end last time, were talking about something which is called the Condorcet paradox. Condorcet is the name of a French mathematician, political science. This is like a long time. I think Condorcet was like in the late 1700s, old school kind of guy. But anyway, the idea is if I have some kind of a situation in which people are ranking their choices, and remember how to read one of these little charts is, this means that 30 people voted in this way, that is they like A the best, and then B, and then C. And then another 30 people voted in this way, and then another 30 people voted in this way. So let's just imagine that these are, you ask everybody their opinions about these three options, A, B, C, in order, and these are the rankings that they tell you. What is paradoxical about this is if you do if you sort of count up the numbers here, I would say in A versus B, this is what I said at the very end, so I'm just gonna quickly remind us. If I only look at the rankings with respect to A and B, so just sort of temporarily ignoring the C's, you can see the first 30 people, they like A better. The middle 30 people, they like B better. But the final 30 people, they also like A better. So in A versus B, I will say 2/3 of the voters prefer A, right? Everybody in the first column, there's 30 of them. And everybody in the last column, there's 30 of them, also prefers A, whereas the only ones who prefer B are the middle column, right? 2/3 of the voters prefer A. And if you think this through about all the other comparisons, in B versus C, if I look over here, I have B is above C here, B is also above C here, but B is below C here. So again, in 2/3 of the options, 2/3 of the voters like B better than C. So in B versus C, 2/3 prefer B, right? And if we look in C versus A, you will see A is above here, but C is above here and here. That means 2/3 of the voters prefer C above A. All right. If I was writing this sort of using slightly more kind of mathematical symbols, I would say the group thinks, just like in general, the group as a whole thinks A, would you mind if I write it this way? A is greater than B, right? That's what I said the first thing. 2/3 of the voters prefer A versus B. So A is bigger than B, and B is better than C, and C is better than A. And this is the paradoxical thing, because ordinarily this doesn't make sense really. To say A is better than B. I like A better than B, and I also like B better than C. And I also like C better than A. That doesn't make any sense, like logically speaking. This makes some sort of a weird circular thing, which is illogical, all right? This doesn't make sense. All right. Would you mind a little more fancy terminology about this? There is an old fact that I'm sure you've heard of this, although I don't know if you remember the terminology for this. This is an old math fact about numbers. It says if you're talking about like numbers, if x is greater than y and y is greater than z, then x is greater than z. Everybody knows this fact. If you have one number that's bigger than another, and then that other one is bigger than something else, then it means the first one is bigger than the third one, right? This is a basic fact about numbers. Anybody remember, there's a name for this? This is called the property of numbers. They talk about this for the equal sign also. It's also true that if x equals y and y equals z, then x equals z. It's the same kind of property. Anybody, does this sound familiar to anybody? Yes? Anyone remember actually the name for this? Usually kids learn, to be honest, I'm actually not sure why we teach kids this property, but this is called the transitive property. This usually goes together with the reflexive property, which says, if you're talking about the equal sign, the reflexive property says x equals x is always true. And then there's the symmetric property, which says if x equals y, then y equals x. And then there's the transitive property, which is this kind of thing with three things. All right? The transitive property. And now, this is a fact about numbers, but this is also, generally speaking, true of people's preferences. If I like one thing more than something else, and I like that other thing more than yet another thing, that means I like the first thing better than the third thing. All right? So, I will say individual preferences are transitive. That is to say, transitive, right? If I like my mom more than my dad, and I like my dad more than my sister, that means automatically I like my mom more than my sister, just because of the way that works out, all right? Individual preferences are transitive, but when we combine people's preferences together, as we did up here with the A's, B's, and C's, right? Up here, we saw in this example, the group thinks that A is better than B, and B is better than C, and C is better than A. That's backwards from the transitive property, all right? So individual preferences are transitive, but when we combine people's preferences together, the result may not be transitive. And this is the big sort of paradox. May not be transitive. What it means is that there really isn't any reason to expect that the group preferences make any logical sense. So the moral of the story is groups of people may not have any logically sensible preferences. I want to change this word to might. I don't want to be misunderstood here. Groups of people might not have any logically sensible preference. Right? Sometimes a group of people actually does have a shared opinion, but sometimes if you try to ask a group of people what their opinion is, there just simply isn't any answer that makes any sense at all. All right? This is kind of bad news from the perspective of democracy lovers like myself and like all of you, I'm sure. What it means is, like, the basic idea behind democracy is, in order to make a decision of us all together, what we should do is somehow vote about it so that we can figure out what we all as a group prefer. But what the Condorcet paradox says is that actually, in many situations, there is no such thing as what we all as a group prefer. So this is what you can, tell your friends at lunch about. This is like the tweet version of this, the sound bite. Sometimes there is simply no will of the people, which unfortunately this is like the basic idea that democracy is supposed to be aiming at. But sometimes the people as a whole do not have any logically coherent will. And in that case, what's the point of even voting if there's no such thing as what the people want? This kind of thing that, Condorcet, like I said, lived a long time ago, and this sort of thing was known to even the people who created the United States. I believe Ben Franklin was, I don't know if he knew Condorcet, but they had similar contact with each other's ideas. And this is one of the reasons why Ben Franklin had this famous quote that democracy is the worst form of government except for all the other ones that have been tried. That's supposed to be some joke. But I think Ben Franklin understood that the basic idea behind democracy in some sense is kind of fictional, because sometimes there just is no such thing as the will of the people that you are allegedly trying to measure by voting. But what else are you going to do, right? I mean, that's the unfortunate reality of things. I'm not trying to say that there's no point in voting in these situations. It's just I don't have any better ideas. But anyway, so what I would like to be talking about for the next couple weeks is sometimes there's no will of the people, but I will say it this way: we still got to vote. Because I don't have any better ideas, and in my opinion, nobody else has any better ideas either. We still have to vote, so let's try to do it. Let's try to use the best methods possible. And unfortunately, when people talk about methods of voting in real life, those people are often sort of clouded by political considerations. If you ask politicians about how we should do voting, typically the politicians will give you an answer which benefits them, right? They want to use whatever system makes them into the winner. If you look at, that's how people in the real world often think about this. But I want to talk about various different ideas. So I'm going to compare mathematically. That says mathematically. Mathematically, a few different systems. And this will involve describing, okay, here's a few different ways that we could do voting, and then here's some very specific ways that we can try to measure which one is better than another one, all right? And not ways like, I just kind of like this one and I don't really like that one. That's not really good enough. I want to talk about very specific sort of mathematical tests which you can do, which will tell you if this voting method or whatever is better than another one. All right, so this is where we're going in the next few weeks. Let's get down to some real details. I feel like I've been just sort of talking a lot in the class so far this week. It's not really my intention to stand here and talk all the time. So today we're going to get to some specific things. I'll have some sort of stuff for you all to work on, and I'm going to walk around and see how you're doing. This is just to make sure that everybody is paying attention. All right, a few different systems. We have already talked about the simplest of the systems, and that is the plurality system. So the plurality system is the simplest one. This is the one in which you only care about people's first choices. And in real life, if you're using the plurality system, you don't even ask them about their other choices. But in the plurality system, all that matters is the first place rankings. So you just count up the first place rankings, and the one with the most wins. All right, that's called the plurality system. It involves ignoring all of the rankings. All you look at is the first position. So, for example, this is basically always easy to do. If I give you, and you'll see, some of the homework problems are like this, and I hope that this seems easy to you. I will describe to you a bunch of people and their votes. Let's say I am having an election, and this is the way that people vote. These are their rankings. I think there are 100 total voters in this one. All right. And your job, I will say something like, find the winner using the plurality system. Right? This would be like a typical homework problem, a typical test question. This is an easy one because the plurality system is so simple. What I said at the top there, just count up the first place rankings and the one with the most wins. So since I'm doing the plurality system, actually I don't even care about any of those things, right? They are irrelevant for the sake of doing the plurality system. The only thing that matters is everybody's first place votes, and we can just add them up. So A, how many total votes are there that put A in the first place? Well, everybody in the first column, that's 25 votes, plus additionally everybody in the second column, that's 37 votes. So the total number of votes for A in the top position would be 25 plus 37, which is 62, I believe. Incidentally, this is like the most complicated calculations that you're going to have to do for these. I said before that we're not going to be using calculators on our tests, and I hope you're not. I hope that this is okay for you to be able to do calculations on this level. You will have to add numbers together. I hope you can handle it. We will, once I believe, there's one thing that we're going to talk about all semester which involves multiplying. It'll be fine though. All right, anyway, that's the votes for A. We got to also say, what are the votes for B? What do you say? Yeah, just 38. The third column there, those are the only people who put B in the top position, and that's 38 of them. So this one is just 38. And then C, how many votes for C in the first position? The answer is 0. Nobody put C up top. All right? And so who is the winner? You just look at these three numbers and you pick out the biggest one. That is the biggest one. So A wins. I don't know about you. I always get excited and put an exclamation point when somebody wins. You don't have to do that, but this is just how I feel. A is the winner. All right? This is the plurality system. If you are correctly understanding what I'm doing here, I hope you feel like this is easy. There's not much to it. All right, let's just try one more example. How about this somewhat more complicated chart? Here I have 4 candidates, A, B, C, D. Doing the plurality system, it really doesn't matter that much. It's not much harder. So I have 14 said A, B, C, D. 10 people said C, B, D, A. 8 people said D, C, B, A. 4 people said B, D, C, A. And 1 person said C, D, B, A. All right, here's another example. Actually, this particular example we're going to come back to when we learn about other methods for doing for finding the winner. But anyway, let's, again, find the winner using the plurality system. All right, you just have to add up for A, B, C, D, for each of them, how many votes are they receiving in the top position? For A, the only votes they get in the top position are from the first column there, and there are 14 voters, so A gets 14 when I look at the plurality for A. For B, really, you are only looking in the top row here. How many people put B in the top position? What do you say? I heard someone say 4, I think. It was just a whisper. I felt it in my heart, though. What about C? This is the hard one. It's not really hard, but 11. Yes, I have 10 votes for C from these guys, and then one more vote for C from this column. So it's the total for C is 10 plus 1, which is 11. And then D, I see right in the middle, 8 voters have put D in the top position. And so, again, the winner is A with 14. All right, this is how you find the winner using the plurality system. It's very simple, in my opinion. Any questions about that? Thoughts about that? Okay, great. Let's talk about a more interesting system. Sorry, one more thing to say about this is I will just note, I mentioned this before, but I will note again. Note. You don't need a majority to win in the plurality system. Majority means you got more than 50% of the vote. That's what the word majority means. But that is not necessary in order to be the winner using the plurality system. All right, in this example, if you work out like how many, sorry, I just realized I wrote 10 plus 1 equals 1. This is not correct. 11. I said 11, right? I think so. You don't need a majority to win. Like in this example, if you think about how many voters are there total here, if you add all these numbers, it's 24 and 32 and 36 and 37, I think. 37 total voters. If you think about what's a majority of that, I think a majority of 37 would be 19. That's if you divide that by 2 and then round it up. Is that 19? I think it's 19. You don't need a majority to win. So in this example, 19 votes would be a majority. And none of the candidates got 19. So there is no candidate here who is actually preferred by a majority of the voters. But that doesn't matter. It's not necessary to get a majority in order to win in the plurality system. All you need to get is what they call a plurality, which just means you got more than everybody else. So 14 wins because 14 is more than all of these other numbers. It's not because it's a majority, though. All right, this is all we really need to say about the plurality system, I think, because it's so straightforward. The first item on your checklist is the plurality system. You should expect a test question just like this. And if you feel good about that, you will do great on that question and you will get your full credit. Any remaining questions about this plurality? I have some examples for you to try, but this is so straightforward, I think we can do one more thing first. Let's talk about the first kind of more interesting example, or more interesting system, method of finding the winner, which actually does take into account the other rankings. The plurality is very simple because all you do is look up across the top row and you just ignore everything else. But that's not a great way to do it. You should somehow incorporate the rest of the information, right? So our next and first sort of real sophisticated method is what they call ranked choice voting. And this is a real thing that is used in real life elections. Actually, in some places in the United States, they use ranked choice voting. I'm going to always say RCV for ranked choice voting. And just a little bit of, this has existed in the world for a long time, a little bit of history about this. This is also called instant runoff voting. I actually prefer this phrase, instant runoff, but for whatever reason, like mathematicians refer to this as instant runoff voting, but in ordinary parlance and in our politics, this is referred to as ranked choice voting. So I'm not going to argue with them. Or this is sometimes also called the transferable vote. And you'll see why when I describe how to do it. And it's used in real life in Australia. Actually, they switched all of their elections to ranked choice voting, I believe in the 1920s. Like, they've been doing it for a very long time. I think I wrote down somewhere. No, I did not write down somewhere. Anyway, they've been doing it for a long time in Australia. Also in Ireland. And the great state of Maine, and also the great state of Alaska. Maine and Alaska do all of their elections now using ranked choice voting. Are any of you from Maine? Have any of you ever actually participated in a ranked choice voting election? I went to college in Maine, but that was before they started doing ranked choice voting, and I wasn't really interested in politics anyway. The only thing I remember about Maine politics, you can look this up, this is a true story. There was a guy running for Congress in Maine when I lived there, and he had like campaign signs all over on the streets or whatever. A gentleman by the name of Dick Sweat, which all the college bros thought was hilarious, and they were like, "Yeah, I'm gonna go vote for Dick Sweat." And I think he won actually, perhaps because of those bros. I was not interested enough to vote, and I felt weird about voting for a guy just because he had a funny name. I'm not sure what Dick Sweat is up to these days. But he could have gone by Richard, but he chose to go by Dick. That's what's interesting to me. Anyway, so it is used currently in the state of Maine and Alaska, and it has been fairly controversial in both of those states. And there are many other states where people really want to change to the ranked choice system. People who don't like plurality system, they want to change to the ranked choice, and they have had various levels of success. I believe in Massachusetts, maybe 3 or 4 years ago, it was an official ballot question that they asked. There was I think it was during the last presidential election, they also asked people to vote, do you want to change to ranked choice voting in Massachusetts? And that initiative failed. So they, when people voted on it, they said, we don't want to change. So there are different viewpoints about this. But anyway, let me tell you about how to do it. So what's immediately more interesting about it, I'll leave it up to you to decide if it's better or not, but one thing that's more interesting about it is it uses the other rankings. By other, I mean not just the first place. And this is what makes it more sophisticated. The plurality system only looks at those first choices across the top row, but the ranked choice voting actually uses the other rankings, and that's kind of the whole point of it. It uses the other rankings. Here's how it works. You do the election in rounds, and each round we drop, can I say eliminate, since that's what I'm usually going to say? It's like you start with all of your candidates all together in the election, but then you do these rounds where each time somebody gets knocked out, and then there's sort of one guy left at the end, and that becomes the winner. So in each round, we eliminate the candidate with the fewest first place votes. All right? And eventually you get down to just 2 candidates because you're eliminating people. Eventually you get down to just 2, and then between those 2 you just do like an ordinary count and see who wins one or the other. All right? This is how we do it. When I say you do the election in rounds, I mean these rounds are sort of only mathematical. You don't actually ask people to come back and vote. It's not necessary to ask everybody to do another election because you have already gotten all of their preferences. You'll see what I mean. Let's just try an example here. I am going to try a big one here. So our job is to find the winner using ranked choice voting. All right, here is a big example. How about 38 people said A, B, C, D. 15 people said B, C, A, D. Another 15 said B, C, D, A. 7 say D, C, B, A. Sorry to make you copy all of this down. 10 said C, B, A, D. And finally, 15 said C, B, D, A. All right. This is our original setup. So when you ask everybody to vote, these are what the votes look like in a ranked election. And now I want to find the winner using ranked choice voting. So we do this in rounds, like I said. So I'm going to say round 1. What happens in round 1? My description, what I wrote up here says, do the election in rounds. In each round, we eliminate the candidate with the fewest first place votes. So in the first round, you have to count up all the first place votes as you would if you were doing the plurality system. So the first place votes, this is as you would count if you were just doing plurality. I'm going to have a total for A, B, C, and D. And whoever the loser is gets knocked out, and then we recalculate in round 2. So anyway, how many votes do we have for A in the top position? I see 38. That is only the first column. So A has 38 first place votes. What about B? I see a 15 and another 15. So adding these two 15s together gives me 30 first place votes for B. So this is, just to be clear about it, 15 and 15, which is 30. All right, C. Again, there are 2 columns with C on the top. There's a 10 and a 15. We add them up. I got 25. So this is 10 and 15. They add up to 25 votes in the top position for C. And D, only 7, right? Just the 1 column there. D gets 7. All right, so you might say A wins in the first round, but that actually is irrelevant. When you're doing the ranked choice, what's important is who gets eliminated in each round. And the answer is the person with the fewest amount of votes. So in round 1, D is eliminated. All right. And now we recount the votes, but this time with no D's in it. So what we're going to do here is, let me just write that down. Now, recalculate, but without D's. All right? What that means is I'm going to take the original chart up there and just remove all the D's from it. Now, you could, if you really know what you're doing, you could just sort of X them out, although I know this is much harder for you to do on paper than it is for me. It's actually a little bit better to redraw this chart here. So what I'm doing is I'm Xing out all the D's. The effect of that is these people, so it has effects everywhere in the chart, but most importantly right here, these people who used to put D as their first choice, now that D has been eliminated, their first choice now becomes C in the second round. All right, so this actually, this whole chart here in round 2, this whole chart here now looks like 38 said A, B, C, and the D is gone. 15 said B, C, A, and the D is gone. Another 15 said B, C, A with no D. Interestingly enough, these 2 columns of 15 are now the same, because if you exclude D, their rankings become the same as each other. Anyway, these 7, they used to say D first, but D has been eliminated, and so now their vote counts for C first instead. And then 10, C, B, A, and then 15, C, B, A. All right? This is what the votes look like in round 2. And you can see a little bit here about why the other terms, so one other term for ranked choice voting is instant runoff. You could say this is like doing a runoff election, where you are doing the election again, but with fewer candidates, but you don't actually make people vote again. It's an instant runoff because you can just mathematically calculate this right away without actually having another election. It's also called the transferable vote. The reason they say that is because if you look at these 7 people, they voted for D as being first. D lost in the first round, and so automatically their vote is transferred to C because now C is at the top of this column. That's why this is sometimes called the transferable vote system. But anyway, this is round 2. We count again. Count again. So now I have only A, B, C. But we do the same thing. In this case, A has 38 votes still. No change for A. There's also no change for B. I still have the 15 and the 15 for B, and that's it. But so that's 30 for B, right? But C actually has gotten a little boost now. That's because the people used to put D up top. Their votes are now being counted for C. So now C gets 7 and 10 and 15. 7 plus 10 plus 15, which is 32. All right? And so who gets eliminated? B is eliminated. B eliminated. B is eliminated. All right. We're getting somewhere. Now it's just down to A and C, and we do this all one more time, and we will have decided the winner. So round 3. This can sometimes take you a few minutes to do, unfortunately. When this is done in the real world, of course, this is all done by computers, and it's very easy to do if you're using a computer that's sort of purpose-made for doing this. So in round 3, I am going to scribble out all the B's from the chart up there, and I will copy it down just from A's and C's. So those 38, if you eliminate the B, it's just A's and C's. The 15 will now say AC. The next 15 will also say CA in both of these 15s. I'm reading these columns here, but ignoring the B's because B has been eliminated. Next column with the 7 up top says CA. Next column with the 10 says CA. Next column with the 15 says CA. All right, and now we count up all of these. We have A gets 38. I actually was feeling like A was pretty strong in the first round, but A is kind of getting screwed at this point because all those other people like C better than A. So A gets 38. C gets whatever all of those other things add up to. 15 plus 15 is 30. That would be 37. 47 and 62, I believe. This is the kind of mathematics that I'm not great at, but I'm decent. No better than you guys, I'm sure. All right? And now you could, technically what happens now is A is eliminated because they have less, which means C is the winner. I'm usually not going to write all of that out. I will just say C wins. Once it gets down to a one-on-one, somebody's going to win at that point. All right, this is how you do ranked choice voting. Anybody got questions about that? I don't see any questions. I got one for you all to try. So like I said before, I would like for you all to try this, and then as you're sort of working it out, I'm going to walk around and see how everybody's doing. I'm not going to collect this or grade this or anything like that. This is just an opportunity for me to make sure that everybody's doing great, and I am here to help out. So I would like you to decide the winner using ranked choice voting. So this is what the homework is on Wednesday. It's just a bunch of different examples where you will either decide the winner using plurality or using the ranked choice voting. Decide the winner using RCV for this election here. This is actually one that we did a few minutes ago, exactly the same example using plurality. 14 said ABCD, 10 said CBDA, 8 said DCBA, 4 said BDCA, and 1 said CDBA. All right, see what you think. it should go more or less like the one that I just did. A little easier maybe. The numbers are a little smaller. Please let me know if you got questions as I'm walking around. If you don't want to talk to me, that's totally fine too. Scribble it out method is sometimes confusing, but if you can handle it, that's fine. Can you do it here? It's not going to get better, unfortunately. All right here? Yes. You good? Okay. Maybe I'll start doing it slowly up here, so don't look if you don't want spoilers. It looks like folks are pretty much done. I'll give you another minute. I'll just keep on writing my answer, and then we'll talk about it. All right, can we chat about it? Great job, everyone. Nobody wanted to talk to me as I was walking around, which is fine. I don't take it personally. I really wanted to talk to some of you, not specific ones of you. I hope that everybody agrees with me. When you count the first votes in the initial round, I got 14 for A, 4 for B, 11 for C, and 8 for D, which means B is eliminated in the first round. And then when we eliminate B, we get a chart that looks like this when you remove B's. Now, as I was walking around, I saw some people, rather than writing the chart again, just sort of did this. That is okay with me if you know what's up. And then for the subsequent rounds, in the second round, these are the totals that I got, 14, 11, and 12. And so C with 11 was eliminated in the second round. And some people who sort of redrawing the chart haters just would like scribble out the C and then count it up between D and A, and D is on top more often, and so D is the winner. This is fine if you want to do it that way, but it's like morally fine to do it that way. But for the sake of me reading your answers on the homework or on a test, you got to write something more than that. Because if you just do this, if this is all I can see, and then you say D wins, I really don't have a good sense of what you were doing or whether you were doing it properly. You just said who the winner was. So you got to write something. Now, if you are a hater about rewriting this thing every time, I can understand that. But at least write down the intermediate round totals for me so that I can see that you were doing something appropriate to get the answer, rather than just sort of scribbling a bunch of stuff on the chart and then telling me the answer. All right? I don't doubt that you can do that in your head, although I don't think there's any reason to do it in your head. And for me, in terms of evaluating you, I can't tell what you're doing if you write it that way. Anyway, the final answer here, I got 23 votes for D and 14 for A in the last round, and so D is the winner. Does everyone agree with my numbers? I hope that I added them up properly. All right, this is how we do the ranked choice voting. Now, why is this a good idea in the real world? A lot of people really like this system in real life. And it involves something like I imagine, I like the idea of ranked choice voting in the real world because, as I said last time, I don't really like the dominance of the two parties in our politics. And what if I sort of, in my political opinions, this is a silly example, what if I think that actually my mom would be a great president? I think my mom would be better than Trump or Kamala. And so wouldn't it be nice if I could vote for my mom? I should vote for my mom if I really feel that way. And the obvious response to this is, no, you absolutely should not vote for your mom because there's no way your mom is going to win. And so if you vote for your mom, you just might as well not vote at all. That is not true in the ranked choice system. If you can imagine, if I was using the ranked choice system and I had my vote between my mom and Trump and Harris, I could say my mom first, then Harris, then Trump. And you all say, yeah, but your mom is going to lose. And I say, no problem. If my mom loses, then she will get thrown off from the first position. My mom, let's be honest, would lose in the first round. But then she is removed from my vote, and now my vote can count for Harris instead of my mom. All right? This is why people like the system. It allows you to vote for somebody, even if you don't think they have a good chance of winning. You can still put them on the top of your list if that's how you really feel, with some kind of promise that your vote will still be counted if that person ends up being eliminated. That's the basic idea behind the system and why people like the system in real life. There are reasons to not like the system, though, which maybe we will get to in the future. I think I'll leave it at that. See you next time. Check out the homework assignment. Please let me know if you have a hard time finding the homework.